Hello everyone. Today in this video, we are going to see the fundamental principles of atomic structure, right? Atomic structure, we are studying in this series how the atoms are invented, what is the inside of atom, and what every scientist has done, the histories and discoveries that we have seen, okay? Dalton's atomic model, Thomson's atomic model, Rutherford's atomic model, and then the Bohr's atomic model we have studied till now. So the fundamental principles after the Bohr's atomic model, some studies been going on, and fundamental principles of atomic structure been finally put forth by the quantum physics, which is a branch of science. And yes, these principles are we are going to study in this video. So let's get started. So yes, the fundamental principles of atomic structure. So here, atom or atomic structure is consist of two parts. Atom consists of two parts. One is nucleus and second is extranuclear part. What is nucleus? How it has discovered? We have seen the Rutherford's gold foil experiment where he has published a nuclear model. Okay, so from there the nucleus has come into the picture. Nucleus and the extranuclear part. I hope you remember in the extranuclear part electrons are there, but still I'm reminding you here. So nucleus first, it is positively charged. Why it is positively charged? If you see in this video, it will be very long to explain everything. So if you want to know everything about nucleus, go and see the Rutherford's model that I have explained in the last video. So yes, nucleus is positively charged and almost entire mass of the atom is concentrated in the central part, that is the nucleus. And yes, these 2 points we have discussed. The third point is added, the new one. What is that? Nucleons. And what is that nucleons? The subatomic parts of the atoms are called as nucleons. So there are two subatomic particles in the nucleus, okay, which are the protons and neutrons. Protons and neutrons. For your sake of understanding, I have created here one tree diagram. You can see here this atom, right, at the top one. The atom is divided into two parts here, nucleus and extranuclear part. In the nucleus, as I have said here, two parts are there, protons and neutrons. And as you know already, in the extranuclear parts, there are some electrons, right? Electrons revolves around the nucleus. So in short, you can say that atom consists of three subatomic particles, protons, neutrons and electrons, right? Okay. So we'll first study what is proton, okay? What is proton? So we'll study some basic things. Let me tell you, we'll study the charge, we'll study its number, what symbols and the mass, everything. Okay, the characteristics. What is this proton? The first one is a charge. The charge of proton is positive. Proton, proton resides in nucleus. Nucleus is positively charged. Protons are positively charged. The symbol of the proton is small p. Okay, why we are saying here positively charged? What is exactly the charge is? The positive charge is plus 1e, right? It's plus 1e. E is like a general thing that we are using for this much charge. Okay, what is 1e? Is the 1.6 into 10 to the power minus 19 coulomb. I hope you remember in the 12th standard or before that you have studied the unit of charge is coulomb. Okay. So yeah, that is the proton. It's positively charged and the amount of one positive proton is this one electron charge. And the thing to remember here that the number of protons is equals to the atomic number. Okay, number of protons is equals to atomic number. I hope you remember the periodic table that you have studied. Okay, in that periodic table every element has given some number. Okay, and that number is not a random number. That number has came from the protons. The total number of protons that lies in the nucleus of that element is known as its atomic number. It's a very important concept. Okay. So yes, this is the atomic number. What is the mass? We have studied the charge. We have studied what the number is called at. And then the mass. Mass is equals to 1 U of one proton we have studied. So U is here referred as a Dalton. I hope you remember this is the name of scientist and his given is here for the U, that is 1.66 into 10 to the power minus 27 kilogram. Mass means weight has the unit kilogram. Okay, and for one example I have given here the mass of hydrogen is 1 U. Is the standard unit. Okay, so yes, this is all about protons. Okay. Neutron. Okay, in the nucleus two parts are there, two subatomic particles, one is proton and second is neutron. The name itself, it suggests that it is electrically neutral. Okay, it is neutral in charge. Neutral means it is neither positive nor negative. So electrically neutral, and this symbol is small n, small n. Now we'll discuss the number of neutrons, okay, and the significance of this number. So number of neutrons may vary, means they may be equals to the protons of that element or may not be equal. Okay? They can vary. The symbol is capital N. The symbol is capital N. What is the concept of isotope has invented from here, we'll see in the next video. Till now, just understand this basic concept of this neutron. The mass, we'll discuss the mass. The mass of neutron is approximately 1 U, which is equals to the almost that of proton. Proton charge is positive, neutron charge is neutral, but the mass of proton and neutrons are approximately 1 U, okay? 1 delta. Now, next point is also very important. Proton plus neutron is equals to mass number. What does that mean? The number of protons plus the number of neutrons of the same atoms is gives us the mass number of that atom, okay? As we see, even though these neutrons are electrically neutral, they carry some weight. Yeah, they carry some weight, and the weight is approximately equals to the proton, the mass. So yeah, if I want to calculate the mass of whole atom, I have to add the mass of protons plus mass of neutrons. That gives is the mass number, right? Okay. Next is extranuclear part. Extranuclear part means there was one part that is nucleus and second part is other than nucleus. This extranuclear part. And that thing we have already studied in the Thomson's model. Sorry, in the Thomson's they have invented or they have discovered the electrons, but electrons moves around the nucleus was given by the J.J. Thomson, right? So yeah, in the extranuclear part again there are two important parts, electrons and empty space. Empty space has to be taken the name empty space because empty space also has a significance in its own in the physics. So yeah, electrons is empty space. The charge of electron is negative. The symbol is e raised to minus sign. What is the charge of this electron? Is minus 1e. The charge of proton is plus 1e. The charge of electron is minus 1e and is exactly the same. What about mass? What about mass? Mass of electron is 1800 times less than that of hydrogen atom. Okay, that line is we have already studied in J.J. Thomson's. Okay, when they have invented or they have discovered these electrons, they have already told that the mass of electron is 1800 times less than the hydrogen atom. Okay, so that means when we are considering the mass of electrons, we can say it's negligible. Okay. From the experiment point of view, for the practical applications point of view, we are considering the mass of electrons negligible. Okay. We can neglect it. And what is their position? Even though they are extranuclear part, they are other than nuclear part. They revolve in a discrete orbits around nucleus. Okay. Orbits. The word orbits came from this which model? Bohr stable orbit model, right? Orbit concept as given by this Bohr, scientist Bohr. So yes, they revolve in the orbits, predefined paths, and even though the diagram I have shown you two-dimensional, in reality, these shells or these orbits are three-dimensionals. Okay, point to be noted. Yeah, about electrons, what is written here? The energy of electron is depending on the shell in which they resides, right? The shells K, L, M, N. Okay, different shells are there, and in which that electron is there will decide the energy of electron. Number of electrons are always equals to the number of protons, and hence the electrically atom is neutral. Always remember, number of electrons are equals to the number of protons. Protons carries positive charge, electrons carries negative charge. They balance and cancel each other, and hence the atom becomes neutral. Neutrons are already neutral in charge, so they don't participate in this electrically balancing things. So yeah, here one conventional symbol is given. What is that? A, and down Z, and the symbol. It means that A is what? A is what? Atomic number. Z is what? Yes, it's mass number, and symbol is means the symbol. For example, 12, 6 and C is written here, right? 12 to the top, 6 to the bottom and C is there. It means that the element is carbon, whose symbol is given as a C. 12 represents its mass number. Z represents its atomic number, right? Sorry, A is its mass and Z is the atomic number. And neutrons, you can calculate neutrons. Mass is equals to protons plus neutrons. And here is protons means 12 minus 6. You can calculate neutrons is equals to 6. Mass is nothing but protons plus neutrons. So protons plus neutrons 12 minus protons. So you will get the number of neutrons, right? It's a simple math. So yeah, in this tabular form, I have given you the summary of all the subatomic particles that we have studied, okay, and the quick study, okay. Subatomic particles, protons, neutrons, and electrons. The symbols are given as small p, small n, small e to the raised to the minus sign. Mass is given here as 1.66 10 to the power minus 27 kg is U, and here the charge is given as this in coulomb, and the location in the atom. Protons carries mass 1U, neutrons carries 1U, electron mass is 0 or it's negligible. Protons charge is plus 1, neutron charge is neutral, it's 0, electron charge is minus 1. Okay. Location in atom, protons and neutrons both lies in nucleus, while electrons are extranuclear part. They have orbits around the nucleus. So yes, that was a quick study and the subatomic particles that we have studied in this video. Thank you so much.